the symbol for that is D. So kung bold-faced ang D, that means displacement ang vector. Pero kung D lang siya, no bar on top, no arrow, that simply refers to the distance. Okay. Now we now proceed class to operations of vectors, kani vector addition, and this is what experiment number one is actually all about. So we have here addition of one-dimensional vectors. So when we speak of one-dimensional vectors, these are vectors class um, plotted in one particular axis, or this refers to a motion of an object traveling in a specific axis. Either it moves in x axis, or either that object moves relative to the y axis. Later, when we go now to the topic about a uniform accelerated motion or free falling object, these are perfect examples class for objects moving relative to the y-axis. So one-dimensional gyapon na siya. But this time, wararagod ka na nagtaga ka og bola na kay bulang gunitan imong gitagak on top of a building, or naa kay coin, you allow it to toss. Those are uh, examples of a body moving relatively along the y-axis. But as for objects that we oftenly see moving on streets, like cars, moving on streets, bicycles, even you walking right now on your room, or if you're going towards the school, walking towards the school or towards another building, you can actually describe your motion relative to the ground where you're walking onto, or this time if we refer it now to the Cartesian plane, that ground would represent then as the x-axis. So we describe our motion um, as one dimensional relative to the ground or relative to the x-axis. So one-dimensional vectors class, as indicated here in this slide, are either in the same or in opposite direction. As mentioned earlier, if vectors are described to be parallel, that means to say they are in same direction, and at the same time they do have the same magnitude. But it is also possible that they may be opposite to each other, just like negative of a vector, meaning to say kung negative of a vector, that given vector is having same in magnitude but its direction is opposite. So if vectors are in opposite direction class, their magnitudes are simply subtracted. But if vectors are in same direction, their magnitudes are simply added. Simple rules in addition and subtraction for one-dimensional vector, right? What are gihapon na good in application to the number line? If kung pointing then to the right, it's a number line meaning parallel. If they are parallel to each other, so i-add na to. But if they are pointing then in opposite sides sa number line, so we simply subtract them. Same thing, we apply class to vectors. So in figure 1a, we have here 100 newtons east or to the right, and we also have here another vector pointing to the left. There's 150 newtons to the left. Since they are opposite, so you subtract them. So the answer is 50 newtons. And this time, we have an arrow here indicating to the left. Right? Sakto? Nganong to the left man ang arrow ani or ang direction class in figure 1a? Hello, class. Nganong to the left man ang arrow? Class? Hello?
Kay mas dako ang 150, miss.
And so, kay mas ako ang
The,
150,
the,
that means,
the left man niyang arrow, miss. So, means nga ang sobra kay kanang kuan to the left.
okay. Okay, mas greater actually ang magnitude sa second vector, which is 150 newtons towards the left. So ang overall sum or ang resultant vector niya would bear the same direction of the second vector, which is heading to the left. Wala po na same as if we put this into equation, 100 newtons plus negative 150 newtons. The answer for that is negative 50 newtons. That negative there means to say that the direction of that given vector is heading to the left or west. Okay? And on figure 1b, this time the two vectors are pointing in the same direction, to the right or towards the east. So we simply add them, 100 newtons plus 150 newtons, and this time kay pareha man silang direction, so ang net direction as well sa vector is towards the right. Sabtan class? Hello?
Yes, Miss.
Okay, naka-follow ra. Nick. All right. Now let us continue. So only when two vectors A and B are parallel does the magnitude of their sum equal the sum of their magnitudes, and when they are anti-parallel, that the sum equals the difference of the magnitude. So this is now the summary with the given examples. If parallel gani ang vectors, um, the resultant vector is just the sum of the given vectors, kay parallel man sila. But in this case, if they are anti-parallel, the resultant vector is equal to the difference of the magnitudes of the given vectors. Okay. So, okay. Sige. Now we proceed, class, to properties of vectors. So let's have here three scenarios. So in A, okay, I want you then to pay attention here this time. We have here vector A class heading towards north of east, and another vector, vector B, is connected to that um, and is heading towards east. So we have here vector A, north of east. Next to that, nga giplot is vector B towards the east. And this time, this blue colored arrow represents the resultant vector of vectors A and B. And if you can notice, the way vectors are being added, it's by means of head to tail, just like the given experiment. Diba? It's head to tail because the second vector class is added right next to the arrowhead of the first vector. Igo lang gisumpay ang mga given vectors. So the resultant is always plotted if we follow the head to tail method. This resultant is always plotted from the point of origin or the tail of the first vector to the arrowhead of the last vector. Thus, by representation, we have here vector C as a resultant. It's equal to vectors A plus vector B. Okay? Now, this time, let's have class scenario B. Still, same ang given nato. We have vectors B and A. But in this given case, the first vector being plotted is vector B, right? And the next added vector plotted next to it is vector A. Same gihapon, same length with the scenario A. It's still heading towards north of east. And still, the resultant, head to tail man gihapon eh. Pero ang giuna ra og plot is vector B followed by A. So this is now the resultant, the one in blue. This is the vector C. So by means of an equation, so C being the resultant is equal to B plus A. Now, class, in scenario C, this is now the case. Still, we are plotting, adding the same vectors. A towards the east and vector A heading towards north of east. Take a look now as to how vectors are being plotted. What makes scenario C class different from scenarios A and B? How are the vectors being plotted this time in C? Giun sa pagplot karon ang C.
Dili siya head to tail, miss.
Dili siya
Dili
head to
tail.
tail. Very good. Oh, how are they being plotted this time? Giun sa tanawa. How are they being connected this time? Di man siya head to tail. Giun sa man siya pag-connect. Ang tanawa ha? Vector B towards the right and vector A connected and still heading towards north of east. Unsa ang orientation nila ron? How are they being plotted?
Tail to tail, miss.
Tail to tail. Good. Very good observation. This tail to tail method class is another method of vector addition by means of graphical gani, meaning you are plotting the vectors. So A and B perfectly they are head to tail. That's experiment number 1. But this time in C they are being plotted tail to tail. Tail to tail method or what we call as the parallelogram method of vector addition. Ma'am, unsa naman pud na? This is a different case. Why? Awa ha, vector B, atong giunang plot, and now we connect the next vector by placing the second vector in tail to tail. So gisumpay nato ang tail sa second vector sa tail of the first vector. Where is now the resultant? Since tail-to-tail method is called as a parallelogram method, we now draw class a parallelogram. Okay, looking into this figure, in this vector A, you create an opposite parallel side to that, moni ang broken line. Please follow my cursor. I hope so the rest of you are still following. Huh? Okay, so this is now the parallel side. And then you also create another opposite parallel side of vector B. So the one here on top. The point of intersection class of the two parallel sides, this is where you will be pointing the arrowhead of the resultant vector. So, asa man nato i-draw ang resultant. You draw the resultant this time from the point of intersection of the two tails, or simply from the point of origin to the arrow to the point of intersection of the two drawn parallel sides. So this is now the resultant vector. And if you can see, class, out from this illustration, this diagonal, okay, if makita ninyo, this represents now, class, the diagonal of the given parallelogram. This diagonal is simply the resultant vector, which is having same magnitude with the resultants in scenarios B and A. Walay kalahian. The only thing that makes it different is the way it is being plotted. You are creating here a parallelogram, and the diagonal is simply the resultant. But in the case for scenarios A and B, you are illustrating this by means of head to tail and the given longest leg of your triangle. Kanisha, kaning longest legs sa atong triangle, muni ang resultant vector nato. Now my question here is, pareha ramang di ay ang value sa resultants here in scenario A, B, and C, right? Okay. What property class of vector addition is being shown in this given case? Nga when you add by plotting A and B, that results to C. When you plot by adding first B plus A by means of head to tail, still you get C. And here this time, you are now plotting here by connecting the two tails of B plus A, you still get C. What property of vector is being shown here in this case? Tsaka gipakita diri class nga property. Class, are you still there?
Associative law of
Ha?
addition, miss.
Unsa to?
Associative law of addition.
Unsa to dear? Louder please.
Associative law, miss.
What made you say so? Nga naman kaha. What made you say nga associative siya nga property? Hello? Class?
Like associative siya, miss, kay bisag unsa ang group like AB or like BA, miss, kay same ra gyapon siya answer.
Kay maski unsaon pag again please at i-highlight nato ang idea nimo.
Like
Kay maski unsaon
group,
pag
miss, saan pa group like A plus B or B plus A, kay same ra gyapon siya answer.
same ra gyapon siya answer. Di gyapon siya mo matter. Is that what you mean? Nga either we add first vector A, then followed by vector B, or we add first or plot first vector A, then added next to vector A, the answer is still the same. Is that what you mean?
Yes, miss.
Okay. So, um, the idea here actually is dili siya associative. Okay? Kay kung may associative, we are actually referring here to the grouping of the given vectors. Wala man tagi group diri nga given vectors there. Instead, this reflects one property, addition property, which is called as commutative property, which refers to nga dili mo matter ang order of arrangement, or the switching of the given vectors won't matter to the given overall resultant. And this is the given case, especially sa scenario when we plot first vector A and add next to vector B, the resultant, which is C, is still equal to when you plot first vector B and add with vector A, its resultant vector, which is C, is still the same with the given resultant in situation A. Nakuha ninyo? Like A plus B is just equal to C, and B plus A is just actually equal to C. That is the commutative property of vector addition. So the order of vector addition, or the order of placements or plotting or addition of vectors, doesn't matter at all. Still, you come up with the same resultant. And that is the idea in vector addition. Either you use one method or another, the resultant vector or the vector sum that you get will always be the same. Nasabtan? Baklas? Hello?
Yes, miss.
Hello? Oh, okay. Napa mo dira or basin kuan ha namiya na mo. Wa pa ba oras? 11:24 pa. Sa magigutom na mo? Mura nagkahinay naman atong tingog. Gigutom na?
Yes, miss. Aw,
Ha?
sabot ra miss.
Unsa? Unsa tudong? Di ko klaro. Gutom na?
Dili pa, kasabot ra.
Ah, oh, sige. Kaya pa. Sige. Okay. Sige lang kaya. Happy na tamo end. Okay. Okay. So we have here class another property of vector addition. So take note sa kanina pod nga scenario. This is a different thing sa first example because the first example shows the commutative property of vector addition. So the order of vector addition doesn't matter at all with a given resultant or vector sum. Let's have this case when we have addition of more than two vectors. So we have here class five given scenarios. Okay, so here in scenario A, this tells us the direction of the three vectors. So vector A from the given, it is going down or towards south. Vector B is heading towards east, and vector C is heading towards north of east. Now let us take a look in scenario C. We are now adding class the three vectors. This time we add first the vector A going down, then we plot next to that or add next to that the vector B, and we plot next to B the vector C, which is heading A plus B. We add A first, then we plot B, and this time before we plot a vector C, we get first the resultant of vectors A and B. So A plus B, uh, we get class here this given resultant, which is D. And this time, the resultant of A and B, which is D, we add now the third given vector, which is vector C. The resultant, because the overall resultant now is indicated as R, the resultant vector or the overall sum of the vectors that is still directed here in the direction north of east. So again in B, A plus B is equal to D and D plus C is equal to R. R is the resultant vector. Nakafollow sa scenario B, class?
Yes,
Yes,
miss.
miss.
Okay. Now this time in scenario C, this is a different thing, different case. What is now the scenario class in this case? This time, what is added first is vector B. So vector B towards east. Added next to that is vector C directed north of east. Before gi-add ang third vector which is A, gipangita usa ang resultant of vectors B and C. Therefore, B plus C is equal to E. E is the resultant of vectors B and C. After getting the resultant E, A is now added. So A plus E, the resultant is indicated as R, or the overall sum of the given vectors. So C, again, B plus C is equal to E. E plus A is equal to R. Now, on the scenario D, this is this a more simple way of adding it. Okay, all of the three vectors are simply added. So A plus B plus C, and this is now the resultant R. Still head to tail method. Pareha naman gihapon ang B and C head to tail method gihapon. But the only difference in D is that sa D kay gisumpay ang tulo ka vectors. But in B and C, the first two vectors are being added. Sa B, gi-add first ang A and B, while in C, gi-add first ang vectors B and C. Here, in scenario E, what is added first is vector B, then added next to that is vector A, and Added next to that is vector c. So we have b plus a plus c is equal to r. Now, take note, class, of the given resultants in scenarios B, C, D, and E. Naabay kalahian sa resultant for the given four scenarios? Is there a difference of the resultants? Yes or no? Tanawa ang resultant. Nay kalahian, wala.
Wala, ma'am.
Wala. Okay, pareha ra gihapon ang value sa resultant, right? Either giuna nato og group ang B ug C before i-add si A, or gigroup nato daan ang A and B before gi-add ang C, or gi-add diretso ang A, B, and C, or B plus A plus C, still the resultant is the same. What property class of vector addition is shown here this time? If sa previous example, it shows the commutative property of vector addition, this time, what vector property is shown here?
Associative, ma'am.
Yes, this time mo na ni is the associative property of vector addition. What makes this showing the associative property? Oh,
Katong
sige.
wala na change iyang grouping is yes, same ra gihapon ang resultant nga vector.
Okay, so dili mo matter ang pag-group sa vectors uh, with its value sa iyang resultant. So the grouping of vectors does not change the resultant or the overall sum of the vectors. So either unahon nato og group si A ug si B before i-add si C, or unahon nato group si B ug si C before i-add si A, or adun silang tanan, still ang resultant kay the same. Okay? That's the associative property class being shown. Claro? Claro, class?
Yes, ma'am.
Sige. Okay, good. Now, we proceed kung naatay gitawag nga vector addition, naapatay gitawag class nga vector subtraction, or from the name itself, subtraction of vectors. Mong parihara lagi ni no, when we do the basic processes like addition and subtraction, yes, same gihapon ni ang process. Ang nakalahi lang yun sa idea class sa vectors, especially when we go now to two-dimensional vectors. Kay kani, these are examples of one-dimensional vectors. So, dali ra kaayo ang pag-add o pag-subtract for one-dimensional. But in the case now, kung two-dimensional gani, dili as simple as 1 plus 1 is equal to 2 kung two-dimensional na ang vector, because in two-dimensional vector, a given vector crosses two axes, and that vector is being defined by an angle. So we find the given resultant by resolving the given vector by means of its components. So, diha na ma-apply katong giingon last time ang concept about trigonometry and the Pythagorean theorem. Sige, later we will see it. But this time, 1D pa man ta, one-dimensional, let us now look into vector subtraction. So, this is now the example. We have here vector A minus vector B is just equal to vector A plus the negative of vector B. Does the equation, class, make sense? Right? No? Hello?
Yes, miss.
Mm. So when you subtract, class, a vector, muning meaning sa equation, when you subtract a vector, you're just actually adding the negative of the other vector. So if vector A is subtracted by vector B, or A minus B, is this just equal to A plus the negative of vector B? Or simply, you are adding, class, the negative of vector B. kay you are subtracting A by vector B. Mo na yung meaning ani this given equation. So ma'am, if this time in vector subtraction is simply adding the negative of a given vector, how do we represent the negative of a given vector? This is how you do it. So, nanapod tayo given scenario. So, pay attention. We have here A, B, C, and D. In A, it shows here, class, the direction of the given vector. So, A, directed to the left. How about ang B? Unsay direction ani sa vector B, class? Unsay direction ana?
Southwest.
Southwest. Okay. In B, direction sa vector A is to the left still, but this time the negative of vector B, take a look its direction. Unsay ang direction?
Northeast.
Northeast. So, what can you say now? The direction of the negative of a vector. Awa. B, southwest. Negative of vector B, northeast. What can you say now in terms of its direction?
Opposite siya, miss.
Opposite, yes. As I have mentioned earlier, negative of a vector, it means to say that that vector points in opposite direction, but its magnitude is just the same. Naklaro? Hello?
Klaro, ma'am.
Sige. Now, if we are now asked to find the resultant class by this given case that you're adding the negative of vector B, this is now the case. So here in scenario C, this is how you do it. So vector A plus the negative of vector B, this is now the given resultant. A plus the negative of vector B, maoni ang atong resultant, the one in blue. What method class of vector addition is shown here? Unsa nga method of vector addition is shown here in C? Giunsa gi pag-add, giunsa pag-plot ang given vectors by means of tanawa. Hello?
Head to tail, miss.
Head to tail, di ba? This is vector A. Gisumpay ang negative of vector B. And this is now the resultant. Di ba resultant? You always draw the resultant vector from the point of origin or from the tail of the first vector to the arrowhead of the last vector. So this is now the resultant vector. In scenario D, this is now the case. Vector A added this time with vector B. Tanawa, unsay nahitabo diri? How are the vectors being oriented?
Head, miss.
Head to head. In this given case, this shows the idea of vector subtraction. Okay? Ang vector C, this is vector addition. But in this case, ang gi-add nga vector class, this negative B, this is the negative of vector B. Although you are actually adding the vectors by means of vector addition, still the resultant is the same as A minus B. Why? Because the next vector or vector B, this is the negative of vector B. Muni ang gi-imply sa kaninga equation. A plus the negative of vector B. When you are adding the negative of a given vector, you are simply subtracting the given two vectors. So when you plot now vector A minus vector B, this time you are actually meeting or connecting their two heads. So A and B. But if you opt to use vector addition, di ka ginahan to show this method ang head to head, you opt to use still vector addition like head to tail. This time instead nga a minus b, you do it as a plus the negative of vector b. So head to tail of vector addition. Still, the answer is the same, right? This is the resultant, and this is also the resultant, the one in blue. Unsay directions atong resultant? Mga higala, unsay directions atong resultant?
Northwest.
Okay. Nakasabot, class? Nasabtan? Hello?
Yes, Miss.
Okay. Sige. Okay. Now, this time, we will now be adding class vectors in two dimensions. Okay. Kung two-dimensional gani, I think that's very obvious that the given vector is crossing in two axes. Dili parehas sa kaninga uh, example earlier sa kani. This is a perfect example because of one dimensional, meaning they are just moving relatively in one axis. So, kaninga case, this is moving relatively along the x-axis. So, kung two-dimensional na ganita, um, we can still apply because katong mga methods that is being mentioned earlier, pareha sa inyo perform sa lab, katong head to tail, o kari pong parallelogram, kato akong gi-mention kanina, applicable. And another way as well that we can apply for two-dimensional vectors by means now of computation, that's the analytical method of vector addition. We can use the component method of vector addition if we are given of more than two vectors. But if in a case nga the given two, we are given with two vectors, especially if the two vectors are perpendicular to each other, so we can apply immediately the Pythagorean theorem to solve the resultant vector. Okay. So for the head to tail method class, I think you are already aware with this. Okay, this is what you have performed sa katong simulation sa PhET. Ang pinaka-importante ani is you do represent class the vector in scale. Importante ka ang scaling. And of course, you need to use then ruler and protractor in plotting the given vectors. So just like what we have mentioned earlier, if head to tail method, all you have to do is to plot the first vector. So ang tail niya should always be drawn from the point of origin, and then the arrow here would represent the direction of the first vector. For the second vector, vector b, this one, if you are now adding the second vector, all you have to do is to connect the tail of the second vector to the arrowhead of the first vector. And for its resultant, it is simply creating an arrow from the point of origin to the arrowhead of the last vector. This is now your resultant. And for the given direction of your resultant, okay, we will be using class reference angles here. So that means to say you have to measure the given angle or direction relative from the positive x-axis, and you go up to where the resultant vector is counterclockwise. So if this is your resultant, this is now the positive x-axis, so this is now the angle of your resultant. You go up counterclockwise. That will now serve as the angle of our resultant. Okay? Naka-follow, class?
Yes, Miss.
Yes,
Mm.
Miss.
I have a question here. Why is it important that vectors should be drawn in scales, just like what you did in the first experiment? What is the importance, class, of scaling? Anong kinahanglan na atay appropriate scale?
Para accurate and precise, Miss.
for accurate and precise. Other than that, why do we have to draw vectors in scale? Especially kung graphical method ta. Hello, class. What's the importance of scaling? Usap ni sa question ha sa lab. What's the importance of scaling?
To help represent the magnitude.
Ha? Ano sa to? Please, again.
To help represent the magnitude.
To represent the magnitude. Other than that, ano kinahanglan nato i-draw into scale? Say, if given ka og vector nga 10 kilometers, moving towards north of east with an angle of 10 degrees, how do you plot it kung 10 kilometers ang vector? Maplat ba na nimo? Class? Hello? Hello? Naapa ba dira? Ano kinahanglan matag na scale?
Mag-scaling mo because it it will accurately represent the magnitude of direction.
Yes. We need a scale to accurately and precisely represent a given vector. Say example, with a given case akong giingon, what if ang given nato is in terms of ang unit niya is in terms of kilometers, say 10 kilometers moving in direction of north of east at an angle of 10 degrees. You cannot plot class 10 kilometers in a simple or plain graphing paper because that's too long ang iyahang given distance. So, lisod kayo i-plot. So, to accurately and precisely represent the magnitude of that vector, you need a scale. That's the answer. Okay. And another method, okay, um, of vector addition is by means class of parallelogram method. So, parallelogram is still under the graphical method. But the only different here is dili siya head to tail, but instead you are plotting the vectors tail to tail. So same process, you choose an appropriate scale, and now the given vectors are being placed or drawn tail to tail. So we have here vector u and vector b. So this is now vector u and this is vector v. Both are being plotted at the point of origin. Their tails are being connected. And next to that, you draw class opposite parallel lines to each of the given vectors. If this is vector u, you draw an opposite parallel side, and at the same time, for this given vector v, ang kaniyang opposite parallel side, this is another parallel drawn to create a parallelogram. I think you can see this one is a parallelogram. Now, the diagonal of the parallelogram, which is drawn from the point of origin to the point of intersection of the two parallel sides, this is now the resultant vector, or simply the diagonal of the parallelogram. So this diagonal is simply equal to u plus v. Either you use head to tail or parallelogram method, the answer that you get, class, for the given resultant is still the same. Remember, ang katong properties of vector addition, ang associative and commutative, the order of adding vectors and the grouping of adding of vectors does not affect the resultant or the overall sum. I hope so that's clear. Questions? Nasabtan? Class, hello?
Yes, ma'am.
Okay. Question as of the moment. Wala pangutana?
Wala ra, miss.
Sige. Okay. I will proceed class. Kanina lang, last na lang yun niya siya. This time, we go now to an analytical method of vector addition. We still have class 10 minutes. Okay. Kung unsa naman po ni analytical method, katong kanina that was presented, ang katong head to tail and parallelogram, those are the graphical method of vector addition. This time, naatay another way of vector addition that is means of computation, which is called as the analytical method. Okay, so let's have here class a given example. We have here a man walks 95 kilometers east, then turns 55 kilometers north. You are now asked to calculate his resultant displacement, or you're asked to find its resultant displacement. So, if we will now be illustrating the given vectors, so the first vector, 95 kilometers towards east, the one in blue, and another vector that is directed north with a magnitude of 55 kilometers. Okay, you're asked to find out the value of the resultant displacement. So if we will be illustrating it by means of head to tail, these are now the vectors. Vector 1, vector 2. Where is now the resultant? Asa ganito ang resultant ani class? From tail of the first vector going to arrowhead of the last vector, correct? Okay, so if that's the given case, this is now the resultant. Looking into the given figure, we are actually creating a right triangle, isn't it? Sakto ba class?
Yes, ma'am.
Okay, what does the resultant represent in this given right triangle? Kani, what does this represent?
Hypotenuse.
The
Hypotenuse.
The hypotenuse, correct. The hypotenuse represents the resultant. So if this is now the hypotenuse, how can we solve class the value of the hypotenuse or the resultant vector? What equation can we use to solve this?
Pythagorean, miss.
The Pythagorean. What's the equation?
C squared equals A squared plus B squared.
Okay, c squared is equal to a squared plus b squared. So if we put now class into an equation, okay, we simply get it now as c as the resultant is equal now to the square root of a squared plus b squared. A and b represents class the legs of our given triangle, where a represents class here the horizontal component, or the one being indicated as vector 1, and b as the vertical component, or simply the vector 2 in this given problem. So substituting, c is just equal to the square root of 95 square plus 55 square. So getting the value, the resultant, or simply the hypotenuse of our given right triangle is about 109.8 kilometers. Nasabtan? Class? Hello?
Yes, miss.
Mhm. Based from our discussion earlier, asa man karon ang angle sa ato ang resultant? Asa ang angle ani ron? 'Di ba? We will be using reference angle. So, asa ang angle sa atong resultant? Mo man ni atong resultant. Where is now the angle of our result? Yes. angle of our resultant vector or the direction of our resultant vector. Asa naman ani ron? Ang asang
Opposite sa
angle?
hypotenuse.
Opposites hypotenuse. If this is the hypotenuse, are you referring to this angle?
Yes, ma'am.
Sure. Dili ni mao.
Opposite
Kanindi atong
sa
reference.
vertical.
Opposites of vertical component. Are you referring to this angle?
Yes.
Yes. If that is what you mean, your answer is correct. Remember, akong giingon, this time, when we are referring now to the angle or to the direction, we refer class to reference angle. So our reference axis here would serve as the positive x-axis. So if we draw class here, an imaginary Cartesian plane, please follow my cursor. This would serve as the x-axis. This would serve now as the y-axis, gani y-axis. So from the positive x-axis, you go up counterclockwise to where the resultant is. So go up counterclockwise. This is your resultant. This is now the angle of the given resultant. So if this is now the angle of the given resultant, what trigonometric function can we apply to solve the value of the given angle? Sige, kay mahuman na gyud ta. Para mahuman na ta ani. Sige, unsa atong magamit? Or mahuman, makomplete na. Na naman tay magnitude, direction na
Complementary,
natong kulang. We use, unsa to?
complementary or complementary.
No, I'm referring to trigonometric function to solve for the given angle.
Law of sine.
Mm-hmm. Sure? Na naman tay value sa atong resultant. Nasa tay value karon sa horizontal component o sa vertical component. Nga mao man ni kaha atong angle. How do we solve this given angle? Ala, nakalimot na mo. Unsa gini itong angle gani opposite no sa vertical component, right?
TOA, ma'am.
Oh, unsa man na siya dong kanang towa, ma'am? Unsa gani
Tan-
na siya?
tangent equals to opposite over adjacent.
Kana. Very good. Okay. Sige. So we can use now class. Okay. Padayon ko ha. Okay. Show the solution for that para ma-solve na nato. Okay, we use class the tangent theta here. Kaya mo man ni atong angle of our given resultant vector. Uh, and we have defined that this given uh, angle as opposite class to the given vertical component, diba? And this one is also adjacent as well to the horizontal component of our resultant. So we can use then the tangent theta to solve then the given angle. So tangent theta, what did you mention nimo? TOA, ma'am. So tangent theta is equal to opposite side over the adjacent side. The opposite side here represents class the vertical component of our given resultant, which is 55 kilometers. And then divided by the adjacent side. The adjacent side here represents as the horizontal component, the component that lies along the x-axis. That's about 95 kilometers. Now, getting as the quotient, okay, and multiplying it by the inverse of the tangent, oh, we get now the given value of the angle as 30 degrees. So muna ang complete nato nga answer for this given problem, ang iyang magnitude that's about mo bako ha kadali. That's about 109.8 or rounding off to the nearest whole number, 110 kilometers, 30 degrees. That's the given angle of our resultant. 30 degrees north of east. That's the answer. Claro?
Yes, miss.
Nasabtan? Na-recall na ba ay inyong topics about trigonometric functions and Pythagorean theorem? My class? Na-recall? Okay, sige. I'll stop sharing now. Oh, we're just in time. 1 minute before 12 noon. I'll go back now to the Google Meet interface. Okay. So we just had discussed na class ang katong analytical method. We simply use then the Pythagorean kay ang given nga vectors are actually perpendicular to each other. Now, napay another method na if in this given case, if we're given more than two vectors, and then if the given vectors are not perpendicular to each other, they're being oriented at a certain angle or as it crosses two axes, it is best to use the component method of vector addition. And we will have it then by next meeting. Okay? So by next meeting, kay online man gyapon ta, I want you then to prepare a scientific calculator. Okay, right at the end of my discussion, I'll be giving you then an activity or a seat work to perform, and of course, you need your calculator in solving, for in finding the vector sum or the resultant vector. Okay, sige. I want you now to open your camera class, so I can now take the screenshot for today's meeting. Okay. Okay, open na ta. Gigutom na mo? Kay alas 12 na gyud. Impunto. Okay, sige. As I count, 1, 2, 3, okay, smile sa ta. Bahala gigutom. Okay, sige. In 3, 2, 1, smile everyone. Okay, that's it. So, I look forward seeing all of you class by next meeting. Next meeting online gapon ta. Like what I've said, please prepare your scientific calculator for the given seat work. Goodbye everyone. Have a nice lunch.
Bye, miss.
Okay, ako na i-close ha. Sige.